Imagine traveling to Mars in just 6 months instead of the usual 3 years. Sounds like science fiction? Well, researchers at Ohio State University say it could soon become reality, thanks to a breakthrough in nuclear propulsion. The team has developed a new type of rocket engine called the Centrifugal Nuclear Thermal Rocket, or CNTR. Unlike traditional rockets that rely solely on chemical fuels, this system uses liquid uranium to heat propellant directly, making travel faster and far more fuel efficient. So how does this engine actually work? Let's break it down. Instead of burning chemical fuels in a conventional combustion chamber, the CNTR spins liquid uranium in a centrifuge. The centrifugal force spreads the uranium evenly, generating extreme heat. This heat then transfers directly to the rocket's propellant, think hydrogen, methane, or other chemicals, to produce massive thrust. The result? Higher efficiency, less fuel, and faster travel. For example, a round-trip mission to Mars that normally takes 3 years could be reduced to just 1 year, and a one-way trip could take as little as 6 months. Nuclear propulsion has been a dream for space agencies for decades. Current chemical rockets are limited. They're heavy, slow, and require enormous amounts of fuel. A more efficient system could not only shorten missions to Mars but also open the door to exploring the outer planets like Saturn or Neptune, which would take decades with conventional engines. This technology could revolutionize human spaceflight, enabling astronauts to spend less time in the harsh environment of deep space. Of course, there are challenges. Handling liquid uranium safely, managing extreme heat, and testing the engine in space-like conditions are all major engineering hurdles. The researchers estimate it could take around 5 years before a full-scale test is ready. And while it's still in the experimental phase, the Ohio State team is confident that their centrifugal design solves some of the major problems faced by previous nuclear propulsion attempts. Another exciting aspect of CNTR is fuel flexibility. Unlike traditional rockets that require Earth-supplied fuel, the CNTR could potentially use methane or other chemicals mined from asteroids or the moon. This opens the possibility for long-term, sustainable space missions without relying entirely on Earth-based resources. So what could missions powered by CNTR look like? For humans, a round trip to Mars could happen in 1 year, compared to 3 years today. For robotic missions, planets like Saturn or Neptune could be reached in a fraction of the time, making deep space exploration more feasible than ever. Researchers hope to perform laboratory demonstrations soon to see how the engine performs under extreme conditions. Their work was published in the journal Acta Astronautica under the title, Addressing Challenges to Engineering Feasibility of the Centrifugal Nuclear Thermal Rocket. The team also emphasizes the importance of consistent funding for nuclear propulsion research. Without long-term investment from space agencies like NASA, even groundbreaking technology like this could take decades to reach practical use. With sustained funding and collaboration, nuclear propulsion could become the backbone of the next generation of space travel. This is more than just a faster rocket, it's a potential game-changer for humanity's journey into the solar system. Imagine Mars missions taking months instead of years, and robotic probes reaching distant worlds in record time. Could nuclear propulsion finally take us to the stars? Let us know in the comments. Would you take a 6-month ride to Mars if this technology becomes real? And don't forget to subscribe for updates on the latest breakthroughs in space exploration.